Hello everybody, so today I will talk about calculus. The topic today is about double integrals. So now I will show you the technique. We have the double integral of cosine of x squared plus y squared dA. So we have the boundaries in here. So now I will show you the technique. If we look carefully about these boundaries, this is about the circle, and we know that this is about the radius. So we need to wrap. So we have two circles in here, the small one and the big one. So if we check on the boundaries, they want to find the area between number 9 and number 64. That should be about the radius of number 3 and the radius number 8. Here is about 3 square. This is about 8 square. So the area we need to concentrate, that should be about this one. So in this situation, we have dy dx equals to r dr d theta, and we have s equal to r cosine theta, y equal to r sine theta. So now we have the new double integrals in here. So we have cosine and s. We need to change for this one. Similar for y. dy dx we change for this one. And this one we got about number 3 and number 8. And this one, that's it from 0 to 2b. Why? Because we start from here and they go around in the one circle. One circle, that's about 2b, and they start from the 0 in here. And now we need to calculate about this one. We know that we have r squared and r squared in here, so we can do about factorization. So we got about this one, you got about number 1. So we got about r cosine r squared dr d theta. So in this situation, the integral of r cosine r squared dr, we got about sine r squared over 2 and we put about number 3 and number 8. So we put number 8 and number 3 in here. You got about 1 over 2 sine 64 minus 1 over 2 sine number 9, and we have the integral from 0 to 2b d theta. So in this situation, you just got about 2b minus 0, and we put this one similar, go in here. So you got about b multiplied with sine 64 minus sine 9, and this is approximate about 1.5956 4, and this is the final answer. That's the end. Thank you for watching.